Now let's quickly get into the topic of ratios. So I'm going to use an equivalent example I used in an earlier video. So colored squares in a box. So let's say we have a box with 12 squares. 3, 6, 9, and 12. And let's say that 3 are colored blue and 4 are colored green. Okay. So first ratio. How do we represent a ratio? To represent a ratio, you use kind of this notation. So you write some number to another number. So the way you explain this is, the way you would say this is a ratio of a to b. And sometimes you'll get people saying that this is equivalent notation to a and b. And you kind of have to be careful about what this right here means. So let's just get into that real quick. So what if you wanted to say, what is the ratio of blue squares to green squares? Well, that's easy. You know that we have 3 blues and 4 green. Again, equivalent to writing 3 over 4. Now what if we wanted to do the reverse? Say, what is the ratio of green to blue? Okay, so we would do the same thing. We have 4 green, 4 blue. So whatever you mention first, that's the first number you put. So we said green in this case. This kind of serves as a representation of what you're comparing to. And then this is whatever the second comparison is to. So now what if we wanted to say, actually before I move on, this is kind of like the gist of it. But here's where it can get tricky. I want to mention this first before we move on. You got to really understand what these fractions really mean. We know that the total squares, there's 12 total squares. Now, if you wanted to say what is the ratio of blue to total, you would do 3 to 12, which is equivalent to 3 to 12. So you kind of have to be careful between using these two. This kind of, on one hand, it's the same as saying blue to total, ratio of blue to total, or you can think about this as fraction blue colored squares, or what is the percentage? What is the percentage of blue colored squares? If the question asked that and you wrote this, that would be incorrect. This is not. This is only a comparison of two of the same things, two colored. This right here is a comparison of a color to the total. So for example, if you had 9 boys and 11 girls, and you wanted to say what percentage of the class is boys? Well, we know the total is 20. 9 plus 11 is 20. So the percentage of boys, or just a fraction of boys to the total class, is 9 over 20, or the ratio of boys to number of kids is 9 to 20. That is not the same as saying what is the ratio of boys to girls, which is 9 to 11, or 9 over 11. So it's really what you're referring to on the second part is what you have to be careful about. If you're talking about percentages of something, let's just say boys to the total number of kids, well, since that's what you're referring to, that's your reference point to the total, and that's what you include in your denominator. If it's a ratio of let's just say boys to girls or girls to boys. Girls to boys would be 11 to 9, 11 over 9. If it was girls to everyone in the class, 11 and 20. So basically, you just got to be careful about what you're really referring to and what the question is really asking for, because you might understand what it's really asking for, but write it out the wrong way because you get mixed up. So kind of write down what you know, like I did over here. If the question says this much boys, this much girls, I always include the total automatically and then kind of move from there. So what if you wanted to know whether two ratios were equal? So you have one ratio and then you have another ratio. And let A, B, C, and D just represent any natural number. And you want to know, are they equal? Are the ratios equal or not? So, easiest way of doing this is write out the two ratios next to each other and see if these two products, so this is the rule. If B times C, so the product of the second on the ratio and the first on the second one is equal to A times D. If it's yes, then they're equal. If it's no, then they're not equal. And you can do this the other way around with C to D first and then A to B. So B times A is equivalent is equal to C. And these essentially you can see that they're the same thing. C times B is here, C times B is here, D times A is here, D times A is here. So a very obvious way of seeing this is with fractions. So you got A over B, and you want to know is it equal to C over D. Okay, so let's assume that they are equal. We're just starting out this assumption. Now if this was the case, if these two are equal, like I have this symbol right here, then you can quickly see by cross multiplying that A times D is equal to B times C, just like how we have up here. If you don't know, if you want to see the long way of cross multiplying is just the same way of starting out like this and saying, hey, let me multiply both sides by D, for example. A times D over B is equal to C, and then you'd have D over D on this side, so they would just cancel. Now let me multiply both sides by B. Whatever you do to one side, you have to do to the other. So A times D, and then this would be B over B. So they would cancel, and then the other side. Fraction way of doing it. Wanted the quick way of doing it, just cross multiply. So that is how you see whether two ratios are in fact equal.